here. There we go. Now I can see some people's foreheads. All right. So today we are going to start with hyperbola, the hyperbola, or a hyperbola, hyperbole, if you will. Okay? Hyperbola. Okay? So a hyperbola is the most involved of the four conic sections. That's why I saved it for last. Okay? So because we've got to come up with different things for it, and it takes a little bit more to do. But we can handle it because we're good people. Yeah? So, what a hyperbola is. Okay? Any point, or the hyperbola, I should say, is the set of all points where the difference of the distances to the foci is the same. So, in layman's terms, or in easier terms, the distance from any point, let's say point P right here, okay? So from any point P, the distance to the far foci minus the distance to the close foci is the same for any point, no matter where that P is. Okay? So over here, if we went to, on this one, which is the same, if we subtract those two distances, it would be the same left and right. Okay? Again, it is more, the hyperbola is more labor intensive, but it's labor that you can do because we've gone through A's and B's and C's and all that stuff already up to this point. Okay? So it's more labor intensive, but it's stuff that you can and definitely will be able to handle. Okay? I don't think there's anything more on that one. Oh, I know what, we gotta go back here because down here is the equations of a hyperbola. They are different. Okay? If you'll notice, the left-right opening hyperbola equation has the x in front of the subtraction sign and the y behind the subtraction sign. The up-down hyperbola has the y in front and the x behind. Okay? That is a very big difference. With an ellipse, it was always just the one equation. With a circle, it was always just the one equation. This is more like a parabola, where there are two different equations. Just like with ellipses, hyperbolas are always equal to 1. Different from an ellipse, A can equal B in a hyperbola. Okay? So it's similar to an ellipse in terms of the equation being equal to 1. It differs from an ellipse because A can equal B, which means A squared can equal B squared. Okay? Okay. So we got that. A couple of real-world examples of a hyperbola. If you've ever turned a lamp with a shade on it next to a wall, the shade actually creates a hyperbola on top. If you can see it. A lot of the time you got tchotchke hanging on the wall so you can't see the whole thing. Okay? But it creates one up and a lower one. The sonic boom from a shockwave is in the shape of a hyperbola. The planetarium in St. Louis, the building is shaped like a hyperbola. radio signals, how they send out radio signals. That's in hyperbolic form. Triangulating, all that fun stuff. Okay. Like sands through time, so are the days of our lives of an hourglass. Okay. I don't even know, is Days of Our Lives still a soap opera on TV? I haven't watched a soap opera probably since college. Okay. So, I'm going to take you through the steps today. The goal of today is to take you through the steps to graph a hyperbola. So if you wanted to put this onto a piece of graph paper, again, if you need extra graph paper, there is more up here in the blue folder. Feel free to come up and grab one whenever you feel. Okay. Because we're more labor intensive, we have more steps. So we're going to have like 7 steps today instead of 5 to graphing an ellipse. Yeah? So this is the hyperbola that I would like to graph. X minus 3 quantity squared over 9 minus y plus 2 quantity squared over 16 equals 1. Yeah? So that's the hyperbola that we want to graph. So the very first thing that we need to determine is we need to determine which direction this graph opens. Okay? So first off, we need to figure out the direction of the opening, because that's going to determine the graph. Later on, that's going to determine, so Thursday, when we do equations, that's going to determine which equation we're going to use. Okay? So we should always know which way to open. So they're either going to open up and down or left and right. Which one is this? X first, Y second. Left and right or up and down? Left and right. Do we agree left and right? Okay. I would also concur that this is a left and a right opening hyperbola. Yeah? That will help us with vertices later. That will also help us with the graph later, all that fun stuff. Yeah? So that's step number 1. Just a mental step. Which formula does it follow? Okay? Easy. Second step, find the center. Oops, let me scroll back up. And that's just like we did before. Okay? So we find the center just like we have been doing since really since the vertex in a parabola. We look at H, comma K, and of course we think oppositely if it's inside a set of parentheses. If there's no parentheses there, we think 0. Okay? So this the center of this hyperbola would be at 3, negative 2. Okay? So we can put that point, 3, negative 2, we can mark that with a C on our graph. Okay? Easy one so far. Step number 3, then, we are now going to be building a box around our center. And we are literally going to be building a rectangle box around our center. Okay? And we're going to put it in with dashed lines when we do. Okay? So the first thing that we need to do is we need to look underneath the x squared term. We're going to take the square root of that number, much like we did with an ellipse, right? And that's going to tell us where the sides of the box are going to be left and right. Okay? So 9 is underneath the x squared term. So the square root of 9 is 3. So I'm going to go left 3, 1, 2, and 3. And I'm just going to put a little dash there. And I'm going to go right 3, 1, 2, and 3. And I'm just going to put a little dash there. Okay? That's all I'm going to do right now is just make those little dash. Those are where the left and the right sides of my box are going to end up along those vertical lines. Then what we're going to do is we're going to look under the y squared term. Again, take the square root of that number, and that's going to give us the top and the bottom of our box. Okay? So if we go back up to here, that's 16. Okay? So that's the square root of 16 is 4. So I'm going to go up 4 and down 4. And that's going to give me the box that I need to draw in. And so we're going to dash it in. And that's going to be the box. Now, the nice thing about that box is the no-fly zone. So your hyperbola will never go into that area. Okay? That's your no-go zone. Okay? No-fly zone. The magic of technology. Okay? So we've made our box now. Here's where some labor-intensive work comes in. The diagonals of your box will now form the hyperbola's asymptote. So you need to draw them in with dashed lines because they are slant asymptotes. And then we need to find the equation of them. Okay? So first, we're going to need to draw them in. Now for you, it should be, you can again use something straight, okay? Ruler, edge of the paper, do the fold over trick, whatever you want. Okay? Definitely want to do something straight there. ID, all that fun stuff, and dash those in. Okay? Now, we need to come up with the equations of the line. I will tell you that this, oops, not that one, sorry. That's what I wanted. The slope here, okay, the slope, we've got two lines, okay, so we need to come up with two separate equations. Okay. So the slope for one of the lines is going to be positive b over a. The slope for the second line is going to be negative b over a. So your slopes are automatically always going to be b over a, because if you look at the box both go through the center, correct? Okay, so both asymptotes go through the center. So this distance here, if we're thinking rise over run, we went up b and we ran a. Or we went up b and we ran a in the other direction. Okay? So that's why it's always going to be one positive b over a, one's negative b over a. And they both go through the center, h comma k. Now I say that because, and I'm going to do this one the long way, I say that because you're going to need to remember the point slope form of a line. And that is y minus y sub 1 equals m times x minus x sub 1. Because we have a point, the center, we have a slope, positive b over a, and then we have a slope, negative b over a. So the first one is going to be, so my center again was 3 comma negative 2. So if I use a slope here of positive, so my b was 4, my a was 3, I would get y plus 2 equals positive 4/3 times x minus 3. And I would make that become y plus 2 equals 4/3 x minus 4. So my first asymptote would be y equals 4/3 x minus 6. Then I've got to do it for the other asymptote, which has a slope of negative 4/3. So we just change the slope to a negative. Distribute again. Again, subtract 2. And those are the two equations of our two asymptotes. Okay. Which will be one of the things that you need to find on every hyperbola, the equations of the asymptotes. Okay? Love it. Oops, I forgot. There we go. Abracadabra, I made it appear. All right. Next, we're going to identify the two vertices of this. They will be the midpoints of the sides of the box we just made. They will also be on the sides of the box of the direction of your hyperbola. So back in step number 1, we said that this was a left and a right parabola. So the vertices, the two vertexes, if you will, are on the midpoints of the left and the right sides of the box. So that's right there and right there. They should be in line with the center. So the two vertices here are at 0, negative 2 and 6, negative 2. Those will also be two of the things that I will ask for in a hyperbola. So far we've got center, two asymptotes, two vertices. Okay? So far we're up to 5. Next, step 6. We're going to draw our hyperbola. We're going to draw it in now. How it's going to look? You get a little thicker one. That one's good. we're going to start at the vertice, and it's going to end up going along the asymptotes. So it's an easy draw for you. Okay? If you think back to when we were doing rational functions before a winter break, it's very much the same. It's going to end up along the slant asymptotes, okay? Which is why it helps to draw your slant asymptotes all the way across your graph. Okay? And that was, come on down for me, step number 6. Draw the hyperbola. Fear not, we're almost done. Okay? One last thing. Oops, I gotta move this up a little. Well, too late now. Okay. One last thing is that we need to find the foci. Let me move this down. Oh, why are we jumping around here? We need to find the foci. Okay. The important formula for the foci is the Pythagorean theorem. A squared plus b squared equals c squared. A squared, again, is the number underneath the x term. B squared is the number underneath the y term. Okay. So in this particular case, we had 9 for a squared. We had 16 for b squared. 9 plus 16 is 25. So C, the distance from the center to the focus, that's the same as it was last week in an ellipse. C is the distance from the center to the focus. So C is 5. Okay. Since it's opening left and right, I should say, we're going to add that to the x part of the center. So the two foci are located at 3 plus or minus 5, comma, negative 2. Because our center was at 3, comma, 2. Or 2, 3, comma, negative 2. So 3 plus 5 is 8. So one focus is at 8, comma, negative 2. And the other one, 3 minus 5, is at negative 2. On the graph, we could also do that off of the graph. We could go 5 away from the center. 1, 2, 3, 4, 5. There's one focus. 1, 2, 3, 4, 5. There's the other focus. And then we could say, well, the left one's at negative 2, comma, negative 2. The right one's at positive 8, comma, negative 2. Again, there's a lot of stuff going on with the hyperbola. So we've got a center that we've got to find. We've got 2 asymptotes that we've got to find. We've got 2 vertices that we've got to find. We've got the graph that we've got to do. And we've got 2 foci to find. So there's 8 things to do for every graph of a hyperbola. Okay? And that is it. Okay? So hyperbola, there's our equations again. You have those written down. The steps, just written out. First, find the direction. Then find the center. Build your box. Find your diagonals and draw them in. Find your vertices. Draw it in. Find your foci. Questions, comments, concerns, clarifications? Okay. Let's do one more today. And let's do it together. Okay. We'll do this one together. I'm not going to do much talking. I'm just going to do repeating now. Okay. So you tell me what I need to do. Okay? Which way? Up and down? Because the y's first. Yep, exactly. Exactly. The y's first or the x is behind the subtraction sign. So this would be an up, down, opening hyperbola. Okay? Somebody else. What's next? We got hope. Okay, where's the center? 2 comma negative 3. Do we all agree with 2 comma negative 3? Okay. Again, just like with parabolas from a couple weeks ago, x goes with a, or h goes with x, k goes with y. So they might be in reverse order in these cases. Okay. Love it. We can put that on our 2 comma negative 3. Oh, wait, got the breaks. I got my graph was just too big. Made it smaller so you can see all of them. No scroll. Okay. Next, somebody else? Good. Okay. So left and right, how far am I going to go? 2, because we look underneath the x. Yep. So left and right, we're going to go 2, because we look underneath the x. So I'm going to put a little dash, 2 and 2. Love it. Up and down with our box. You got it. Yeah. 5? Yep, 5. 2, 4, and 5. 2, 4, and 5. There's our box. We've built it. Built by the Home Depot. Okay. Now what? Oops, I forgot to put B as well. Next. For the asymptotes. Okay. And then find them, right? Up here. Maybe not. I like 5 over 2x, and you said minus 8. I like that one. That's this particular one right here. That's that one. Yeah. 2 and not 7. Yep, that one I like better. And y equals negative 5 halves x plus 2. Okay. It's nice when the corners of your box are on the y-axis, because then you can go directly to y equals mx plus b. Okay. If not, then we got to utilize the point slope form. Okay. Love it. Somebody else. Next step. You just had somebody else. I know, that's the problem. That's what we gotta get them. We gotta get them through it. What do you got, Louis? Yeah. So what are they? Which sides of the box? But which sides of the box? Top and bottom, right? Okay, because it's opening up and down. Okay, so you should be able to just look at your graph. Oh, wait, you're doing your homework already, right? So there and there, what are they? Okay. Now what? Draw it in. Yep, that's the easy part. Because you got to stay inside the line. It's kind of like when you were coloring back in kindergarten. Stay inside the lines. Almost went outside the line there. Okay. Last, what do we got to do? Pythagorean theorem. A squared plus b squared equals c squared. Okay. So what's a squared? 4. What's b squared? 25. 4 plus 25. 29. Square root. Square root of 29 is our c. So that's a little bit more than 5, correct? Okay. So since our I almost said our parabola. Since our hyperbolas opened up and down, Aaron, which way should our foci go? Since our hyperbola opened up and down, which way should our foci go? Up and down also. So am I going to add that to the x or to the y? And to what? Of the center, right? So if our center was at 2, -3, that means our foci are at 2, -3 plus minus the square root of 29, which we said was just a little bit more than 5. So it would be in there and in there. Okay? And that gave us our 7 things. So, like on this week's homework or this week's quiz, if we or when we have it this weekend, this would be an answer. These 4 would be an answer. These would be an answer. And then the graph would be an answer. Okay? Questions, comments, concerns, clarifications? There will be a video tomorrow to watch. Okay? Video tomorrow to watch on the It's Learning. It'll be posted and all that fun stuff for you to watch. Okay? Love it. That is all that I have for today. Yeah. So thanks for playing along.